Okay. So this next problem on the test is going to be an improper integral, okay? As with any improper integral, the first thing that you want to do is you want to put a limit on the problem, okay? So this is going to equal, now the limit as b approaches infinity, the integral from 2 to b, that's a dx, of 1 divided by 2x plus 2 raised to the 1/3 power, and this is going to be an integral with respect to x, equals the limit as b tends towards infinity. Okay. Now, when I integrate 2x plus 2 to the negative 1/3 power, right? So this is at negative 1/3. It's going to go up to, all right, so negative 1/3 plus 1 would be 2/3, okay? So it's got to go up to 2/3 and divide by 2/3. All right. So this is going to be 2x plus 2 raised to the 2/3 power and divided by that. But there's something else that we need to consider when looking at this problem, is that there's an extra 2 on this component right there. So when we integrate this, we have to divide by that 2. So there's going to be an extra 2 on this problem. And this is going to be evaluated at 2 and at b. And so that's going to equal the limit as b tends towards infinity, 2b plus 2 to the 2/3 power divided by, and I know I can simplify this, but let's just leave it the way it is. And then minus 2 times 2 and plus 2, there's a lot of 2's, to the 2/3 divided by 2/3 times 2, like that. And then at that point of the problem, we can say, well, that b is on top of that fraction. So since we integrated it, and you can think of this as related to the p integrals where p is less than 1, and so they end up being divergent. Okay. All right. And the last problem on the test is going to be the integral of sine cubed cosine squared of x. Okay. Now for this problem, whenever you're dealing with trigonometric integrals, you're always looking for the odd component. Okay, so that we can use a trig identity, and we can pull that odd component off so that we can do u substitution. So this would equal the integral of sine squared of x times cosine squared of x times sine of x dx, right? And so the integral, we need to use a trig identity on this one, so that's going to be, the sine squared is going to be 1 minus cosine squared of x, cosine squared of x, sine of x dx. All right. So at this point, we can do a u substitution. So I'm going to let u equal cosine of x. So the du is going to be negative sine of x dx. And so this becomes the negative, and that negative right there, of the integral of 1 minus u squared du, which becomes the negative integral of, this is going to be u squared minus u to the 4th du. So I'm going to distribute that negative after I integrate. So that would be negative u cubed divided by 3 and then plus u to the fifth divided by 5, and then plus a constant, which would equal negative cosine cubed of x divided by 3, and then plus cosine to the fifth of x divided by 5, and we put on that extra plus c right there. All right. So that's an improper integral and a trigonometric integral.